Yes, I'm going to review the codes, run them very fast, look at the question and type of the answer that we expected the student to answer, and then I'm going to answer the question if there's any question after this. Yep, thank you. Okay, hello everyone again. I'm going to go start officially here. And let me open the final exam file. Okay, I have lots of problems today with my computer, and let me just open this one. Okay, folder and the final exam. Okay, so okay, I was trying to open. Okay, this is the final exam, and if you perform all the analysis with the weekly exercise, for sure you will not have any problem for the final exam. So there are four questions. The first question is comparing 2011 and 2012, and for three sections. So basically these are the same variables you worked with them before for the weekly exercise. So for this question, the question asks you to just compare the number of observation mean and standard deviation between 2011 and 2012, report the p-value, and then based on your findings, compare the performance between the hospitals in 2011 and 2012, and then please write at least three main differences movement between 2011 and 2012. So this is the question, and if you look at the data set, look at the codes, there is a data set here and there's a codes here. If there is a code for each week, all of them, I put all of them together as a one very long codes, but there is some point in some place. For example, the question 2 started from line 234. Before that, anything related to question 1. And before I'm starting, there are two types of codes. The first one for some of you are working with Deepler package, and the other one is for some of you that for any reason are not able to use a Deepler package. So I'm working now for this exercise on the Deepler package codes. They are the same except for the mean and standard deviation. Any other sections are the equal in between, are the same codes between Deepler and non-Deepler package. So there's not a big differences between them. And if you are working with Deepler package, for sure you need to run this, not running the package, but just load the package. So it's running the library bracket Deepler. And the very important point is you need to make sure you are using the correct data set. The data set for the final exam has only 2000 observation. Make sure your data set is correct. HOSP, this is the same data you use for the weekly exercise, but this data set has only 2000 observation. So if when you are running the code, if for any reason when you add your numbers and your number is more than 2000, so you are making sure that you are doing something wrong. It cannot be possible to have more than 2000 observation. Okay, first of all, making sure, yes. All the data set, all the codes is available at the moment in the class. If you go to the week 8 content, you will see that. Yes, and for the final exam, you need to use final exam dataset, not the week 1 and week 2 codes. There is an announcement in the class that I updated everything on the 8 p.m. 50 minutes 8:15 p.m. Friday night. So if you download anything before than that, make sure to download any make sure to download everything again, please. Okay. Yeah, sure. Thank you. Yes. You could you no you, let's forget about any exercise you perform, so just focus on the code on the data set for the final exam, otherwise you're going to be confused. So it's good, all of the codes you work in the exercise just for was a practice for this final exam. So first things first, make sure to read the correct data set, and then look at the name of variables here. What's happened? Come on. Okay, it is working for some reason. Stay here and then look at the name of the data sets. Um, okay, finally some things here. Okay, here I don't know what's happening today. Okay, it is okay. And if you look at this is the name of variables in the data sets. You don't need to read that, but it's better to read to make sure you are in the correct position. And then this is the key. Line 29 gives you these numbers: 1078 observation for 2011 and 922 for 2012. So if your data set has this observation, you are in a good position. This is the final exam data set. Otherwise, you are doing something wrong. And step 5 generated two variables. You need that later in the class, in the exercise, not for now but later you need that. So you need to generate this one. After running these codes, you will not see anything here, but you can see the blue line here, and the blue line shows that okay, you are doing something correct, otherwise you're going to receive an error. And then you need to categorize the variable year, and then again look at the name of variables. If you look at the name of variable, the two new variables is here: per capita beds. Per cap bed is someplace like here. Where is that? Per cap bed here. This is a new variable 28, and the benefits here 29. So before than that we had 27 of variables, and now we have 29. Okay, this is the summarize comment to see the mean, and if you run this you will see the mean. So I never mind about kind of this error. This is nothing, so you can just ignore this type of error if you have something. This is summarize comment, and the point is, I believe Erica asked me this question before, that if you running the sync command first, let me try with sync. If you're running the sync command, you are not able to see anything here. Let me try with the sync command. This is what you are receiving. This, if you are receiving something like this, it does mean that you are using the sync command. So to get rid of that, if you like to do that, you can just select entire codes, and everything gonna be pasted in the final exam exit text file. But if you like to go step by step, and I do recommend that to go step by step, please close the sync here like this, and run again, run the codes again, and you will see the results here. So this is the result, and you can see this, and you know how to get in. There's a bit more, 3 or more variables here, and you need to give more space. Click on here and drag on the right to the right, and you will see more variable here. So I'm just running here and see I have everything here. This is the means. The second line is a standard deviation, and you know how to convert or how to export entire codes to the Excel file. In the video I just posted in the class yesterday for the previous exercise, previous session, I mean previous class, I provide some codes here. You can just save this one. I believe in some of the one of the exercises go with that. Let me see if it is here. I can show you exercise, probably exercise 3. Yes, this is the codes you can use. Let me go to the final exam here. I can go with, I say, Q1M, and let's call this one Q1 and Q1 standard deviation. And there's other part you need to give, and this is the line, this is the command. You can just write it in the Excel. If I do that, I'm gonna copy this and call it Q1M and Q1S. And if I go with this again, if I running this, I will have object. Okay, of course object is not here. The object is here as Q1M and Q1S. If I'm going so fast, please let me know. I can go slowly. And you will see these two variables here in some place. T1, Q1, it should be in CUMUC. Okay, CUMUC. Let me review from this. I don't like to confuse you. CUMUC is here. Okay, here. This is in CUMUC, and I put Q1M. This is today, 3 and 5:20 p.m. and it's opening here, and this is it. You can see all of them in this. This is the bed, and this is icon, and you know how to do that. So I'm just repeating that from week 3. You can copy, paste the special, and then value transpose, and you click on this. You can see all of the means for 2011, and you have Q1S for standard deviation. What happened to this? Okay, Q1S, and this is okay. Paste special and value and transport. This is all the standard deviation, and then you can, this is means, right? This is unit 3 column here. The first column is n, the second column is mean, the third column is the standard deviation. You have mean. This is 2011, this is 2012, and this is the mean. This is the n, this is the mean, this is the standard deviation. And you can copy from here the standard deviation, and you are good to go. This is the standard deviation for 2011, and this is okay, one variable is not here. Okay, here I copy this one. This is the standard deviation for 2011, and this is the standard deviation for 2012. So this is table 1, and you know how to populate the n. So for n, this is the and for the n. I will explain that later when I go to the code. So the first part is mean, right? This is n, mean is standard deviation. I explained this too. I'm going to explain only one question, not other one. And then the other part, we need to order other part, the n for 2011, for 2012, and the p-value. To run a t-test, you need to have two groups. The first group is 2011 here, and the second group is 2012. So first of all, I need to generate two data sets. These two subset data command just generate two data sets here for us. This is the data set 1, and then I can just run a t-test. The t-test has this one, the t-test, this is a table, this is 2011, 2012, and the code is hospital beds, and you can see the result is a Welch 2 sample t-test, and the Welch 2 sample t-test gives you some t-value, degree of freedom, and the p-value. The point you need to the value you need to copy is this one here, the p-value, and as you see, the p-value for the hospital bed is a 0.1679, and because that value is more than 0.05, more than 5%, there is no significant differences between this is a p-value between 79, the p-value. There is no significant differences between 2011 and 2012. So they have 216 here and 229. And this is okay if you just rounded all of this number or truncated them. This is okay. You can just round them or just truncated them. There is a point here. Okay. In some point it's going to be disconnected. I will go very fast to the next session in case it's disconnected. Okay, I see one of the students asked that I use the log of revenue instead of the revenue in the codes. As I'm looking at here, I think all of them is the cost, this is the cost, and this is revenue, so this is okay. So in case you have a log of revenue, so you can just change that with the revenue, or just you can just convert the data, convert the output to the revenue. But the most easy way is just to use make sure for the revenue use this one, total hospital revenue. This is the variable for the revenue. So you can just run all of this section here, and you're gonna be okay for p-value for all of the question. And then the my table commands gives you the number of observation. So as you see for 2011, this is 11, I have 1078 observation for hospital beds. You can run all of them together to see other observation for hospital beds, for hospital in 2011. And then these lines of codes give you n for the 2012. Okay, this is all the information you need for this table, but the question is, okay, for the section 2b, I already generated code. You don't need to do anything with that. In terms of the socioeconomic, what are the differences between the 11 and 12? Okay, you know, to add your comments here, you really need to look at the p-value. If the p-value is if less than 0.05, you can say, for example, you can say, okay, there is significant differences between 2011 and 12. I do not expect to see any differences between socioeconomic variable between 2011 and 2012. Probably all of the p-value is bigger than 0.05. So, and if all of this more than 0.05, you can say there is no significant differences between socioeconomic variable between 2011 and 12. And for the hospital characteristics, you can just look at the p-value here for these questions, question C, and if any of them is less than 0.05, you can say, okay, that's the differences between 11 and 12, and then look at the mean. the means of the variable. For example, in the hospital file, for example, you look at the hospital bed. I say you consider the situation that this is significant or this is not significant, but I'm gonna give you an example here. For example, if it was significant here, something like this 0.05, then I look at the mean. The mean in 2012 is 211, and the mean in 2011 is 229. So I can say in 2011, more likely I included more bigger hospital. So in case something like this, for example, for the benefit, for the cost, probably you have a lower cost in 2012, and then you can say probably hospital has a better performance in 2011. So this is the answer for this question. What time is it? We have 10 minutes more to for the first live session, or maybe 5 minutes. Okay, this is question one. For the question two, you had the similar question for the exercise. Here, you just need to just compare the differences between for-profit and non-for-profit hospital, and then answer to six question. Compare the following information, and okay, the first question is just to populate the table. The second question is what's the main significant differences, which test is the best fit test and why, right? So we have two population. When you have a two population, the best fit test is which test? It's t-test, correct? So because we have two population, we are going with two t-test, and this and the R studio report a well sample to t-test. So this is the question, and the reason is because we have not more than two population here. Use a box plot and compare hospital net benefits. So I'm gonna review this part. Show another scatter plot and compare hospital cost and revenue. So it's just to show you that, and make sure to attach the box and scatter plot and comparing hospital net benefits. Yes. Okay. I will be here soon to see what's the problem with box plot, so we can fix this. This is here. And okay, this is all the section we already reviewed that, so everything is works here, so I believe there's no problem here. So this is the box plot, correct? And this is the box plot. Okay, you want to see which of them is, I see. Okay, you can just add. Okay, the first one is for profit, the second one is not for profit. Can you see this? For profit, non for profit. You can add a label like okay. No, this is okay. You don't need to add that, but you need to look at to judge, to just discuss your findings. But if you look at any plot and you look at the data set here, this is for profit, this is for non for profit. So based on this, you can just compare. The first one is for profit, the second is non for profit, and in the non for profit there is a more variance here, but if you look at the means here are almost in the same line. So I don't see any differences between mean of hospital benefits, but 2000 but for non-for-profit has more variance, so probably they are not all equal hospital in the non-for-profit. And if you look at this table, when you populated this, probably the standard deviation for the hospital benefit is higher in the non-for-profit than for-profit. Does mean there is a variances between hospital are located as a non-for-profit hospital in the table. This is the point. And this is for box plot, and this is for the cost. If you go with the cost, you can see a plot like this. This is a scatter plot. The reason for this question was I wanted to make sure that you know what's the scatter plot, the difference between box and a scatter plot. And in the scatter plot, for every point into in for profit, you need a point in non for profit. For that reason, you need to use unequal equal to true in the data sets. Otherwise, you are not able to see in the command. Otherwise, you are not able to see this plot here. The same for the revenue. If you go with that, you can see the revenue here, and the revenue is very similar to the cost. So there's so just I believe I didn't ask you any discussion for this, just to see how you are performing the how to understand the difference between two plots. Overall, what the main significant difference is between non-for-profit and for-profit hospital, and you know the point for this is the p-value. You can look at the p-value. If the p-value is less than 0.05, you can say, okay, this is significant differences between between two types of hospitals, but you need to look at the means, and the hospital with higher means are in a better position for the benefits. And okay, this is for this question. And I believe, okay, it's 5:35. Probably I'm not able to go with the next question. I'm started in case do you have any question till now here before I start the question number 3? Because I don't like to interrupt between, when I'm running the codes. Um, mm, yes, Mary. Yes, I'm just capturing this and this. Yeah. Yes, of course. No, that's okay. No, that's completely fine. Okay, we have 5 more minutes for the question number 3. Let me go with that. Okay, and then the line. Okay, this is question number 3. The question number 3 is this. Let me review this and then see. Okay, okay, it was disconnected. Okay, I think it was disconnected at a very good point, right? So we didn't start the oh, you don't have my screen. Okay, class again. Hello again, class. And can you see my screen? Okay, perfect. Okay, here this question number 3. The dataset provide Herfindahl index for the health insurance market. Please use the Herfindahl index variable and answer the following question. If you remember, we had a similar question, right, for the Herfindahl index in the hospital. There is a Herfindahl index in the hospital, and there is a Herfindahl index in the health insurance market. So the only differences between these two variables is probably there are different observation. Otherwise, the way we are generating the Herfindahl index is the same way. But if you look at here, there's 3 markets here: competitive market, moderate, and low competitive market. So the reason I changed that is just to show you that I like to just be a little bit different with the um, exercise. And here you need to make sure about these variables here. Let's make sure that this is the Herfindahl index for the insurance. For these codes, for these tables, you need also to generate 2 other variables: the Medicare discharge ratio and the Medicare discharge ratio. Erica, I believe you are using non-Dipler package, correct? Probably these 2 data set, I put them in the very first. If you cannot see in the, let me see, visit here 441. Probably I'm I'm not sure if I put it there or no. No, this is here in the same code. This is okay. That's fine. I was thinking I just moved them to the very first beginning of the codes, so you have in the same position, no problem. First of all, you need to generate these 2 variables. This is 2 variables here, and I generated them. Then we need to go with the Herfindahl index and generate a categorical variable. You know, you can just what happened to this? Okay, if you can go with the same example I used here, if you want to use Excel to export the data, you can just go with command like this and then save this. Instead of question 1, that's a question 3, right? So the changes here is, you can call it anything you like, but I call it question 1 Q1M and Q1S. And here when you try to export the data, there's two places you need to change, the Q1 here and the Q1 here. So basically if you want to go with question number 3, question number 3 is started from here, and you can go with something like this. Change this one to Q3, Q3 and Q3, and you also need to save this as a Q3, right? Q3M and Q3S, and you are able to see this. You can just, I'm just running, I'm not showing that, but I'm just running and see, okay, it works here, and then it's gonna be exported to these tables. It's already in the CUMUC table. So let's be back to the question. Okay, here, what's the main differences between hospital in different markets use ANOVA test? So because we have 3 groups, so the t-test is not valuable test here, so we need to go with the ANOVA test to try that, and the best fit test is ANOVA. And even for the ANOVA is the same approach you have with the t-test, right? Because the difference is the way you can find the differences is just to go with the p-value. Here, let me run this and show you one of them. If you are running the code step by step, make sure to run this first, line 668, otherwise you are not able to see the ANOVA test. You are not able to run the ANOVA test. And this is the ANOVA test comparing the Herfindahl index as a categorical variable and the hospital beds. And here the degree of freedom is k minus 1. The k is number of groups. So you have 3 groups, and minus 1 plus is going to be degree of freedom is 2. And you don't need sum square, you don't need mean square, and you don't need f value. You just only need this, the p value, the very last numbers here. And I do expect to see all of them is significantly different, because for sure there is some differences between competitive and low competitive markets. This is well known, but so it's better to just run a test and make sure. And then if you go with that, I believe all of them is significant here. Yes, all of them is significant here. All of this number except this. No, this is even, no, this is not significant. Per capita bed is not significant, 0.44. Oh, this is not significant even. Yeah. Okay, that's good. I don't like to answer the questions, but yes, this is not significant. I expect a different way because, oh, most some of them is not significant. But okay, you can compare your numbers here to make sure you are in a good position. So, but here is not significant here for the non-paid worker, and maybe one of them here, maybe there's not enough observation for this. I'm sure about this one, but uh, that's okay. And then you need to go with a box plot here to see is there any question for the box plot? Okay, this is here. What is the impact of being in the high competitive health insurance market on the hospital revenue and cost? Okay, to answer this question you just need to look at the p-value here and then compare the means between 3 different markets. So that's the way you can just say, oh, how's competitive market change the cost and revenue? For sure. Probably in the low high competitive market you expected to see higher revenue than cost. Probably, I'm not sure. But look at the means. Are you gonna, if this is significant, then look at the means. If there is not significant, you can say there is no differences. If it is significant, then look at the means, and the higher market, the higher number is a better performance for that, for the revenue, and the lower market. Okay, let me rephrase my sentence. If you look at the means, the higher means for the hospital revenue is a better performance, and the lower means for the hospital cost is a better performance. The benefit is the cost minus revenue, right? So if you have more cost, less revenue, so you have less benefit. So if the cost is bigger and revenue is uh, lower, so you're gonna have more cost than revenue. So that's the way you can understand this. And the next question asks exactly the same thing I'm explaining here. The benefit, the higher benefit is the better. And so you can just, if there's significance, so you can see, okay, the higher means can show you which market has a better performance. Hospital in which market had better performance. Okay, what about the number of Medicare and Medicaid discharge? Do you think hospital in the higher competitive market more likely to accept more Medicare and Medicare patients? The same approach, that actually the same, the question is changed, only the variables change. The same logic you are working with for the revenue and cost and benefit is the same answer for this. So look at the p-value and then compare these two variables. This compares the means. What's the impact of the other variables? The other variables is the same as these three variables we explained here. Just look at the p-value and then you understand that. No, to answer to the last question, please compute the ratio medical. Okay, we already generated this variable in the data set, and then run a regression model, use the benefit as a dependent variable and hospital bed, Herfindahl index, Medicare and Medicare system. And okay, this is the regression model for this question. And I believe in some point this is a regression model for question number 3. This is here, and you can see the coefficient here. The hospital bed, okay, the hospital is not significant. Herfindahl index is not significant. Total hospital revenue is not significant. Total hospital Medicaid and Medicare is not significant, but system membership is significant, right? So the answer to this, to answer to this question, if you look at this coefficient, you can say which of them has impact, right? So if there is significant, that variable has, okay, this is the p-value less than 0.05, the system membership more likely to increase the hospital benefits. The impact of other variable is based on the direction. For example, the Herfindahl index has a negative impact. Hospital Medicare discharge has a negative impact. All other variable has a positive, but the only variable has the significant impact is the system membership. So hospital, to improve the hospital benefit, one of the solution is just hospital just go, merge with the other bigger hospital and be in the member in the system. So this is the point for the last question, for question number 3. And I believe we have the question number 4. The question number 4, there is the first table, table number 4. The table number 4 is just for populated the table just with an mean and a standard deviation, and then going with the regression model. Let me go to the codes and back here. Yes. Yeah. I believe I removed that. Are you using the previous file or just new file? You are using the previous file because I removed all of the variable that was not in the code. I believe if you download that, I just removed that. I believe Caroline asked me this question in the. Okay. If the code is not here, you can remove that. Yes. Yes. And it's very easy to get that, but remove that. You don't need that. So I'm gonna just will not consider that for grading. Sure. Thank you for noticing this. Okay. This is the same way you can look at the mean standard deviation, and then number of observation is looking at this. This is very easy to go, and that's it. Okay, the ownership. What happened to this? It's not running. Okay. For any reason, okay, I have lots of problem with my computer today. It starts working. I don't know working what, but anyhow it's not working now. Let me go to the question. Hopefully I can see that. Okay. Okay, here question number one, first model. Okay, there is four different regression model. The first regression model is running a linear model and predict the differences between hospital bed and non-for-profit on hospital wage. Discuss your finding. Do you think having higher bed has positive impact on the hospital wage? What do you think about the non-for-profit hospital? Okay, here first of all you need to generate a categorical variables for the ownership, and this code gives you the categorical variable. I did it here. This is the hospital owner. What was the question? Okay, not for period. Okay. Okay. Okay, based on this coefficient, you can see the impact, right? Being on the ownership number, the owner number three, the first one is non-for-profit. I believe in some place there is a code for profit and non-for-profit, right? I believe in some point I explained these codes, the ownership. Okay, here. Let me copy that. Put them here so we can go with the model easily. Okay, where is the table? Okay, first model. You know, everything in the green line is a explanation. So basically the RSU doesn't do anything with this. Just I want to bring them here to see. The first one is a reference group, for-profit, public, and other. So if you look at this, being in the public, in the other hospitals, you more likely to have higher payment. This is the point for the first section of this question. Do you think having higher bed has a positive impact? Okay, the higher bed. Okay, let's look at the. Okay, the bed is yes. The answer is yes. The impact of 1 unit bed is a 5.99 increase in the wage, in the income, personal income. The other variables, the question asks, okay, what's the impact of non-for-profit, and what's your answer to this question? What's the impact of non-for-profit? Do you have any answer to this question? You are not able to see that. It's not zero, basically. You are not able to see that because all of the other coefficient is based on the non-for-profit. This is the answer for this question. Yes. Okay. Okay, and the second model now estimate the impact of being a member of a system and teaching hospital and on the hospital wage and discuss your findings. Not more than 2 lines. Is it significant? Okay, the second model is this one. I just added the hospital teaching and system membership. Okay, this is it. The system membership is significant and positive, correct? System membership is significant and positive, and teaching hospital is significant. It is not significant, but it's positive. So the answer is question is clear, right? This being in the system membership is positive and significant, but being in the teaching hospital is positive, but it's not significant. This is the answer for this question. You can just discuss 1 or 2 lines. And number 3, let me read the question. Number 3, now include the ratio of Medicare and Medicaid in your model. How do you evaluate the impact of having higher Medicare and Medicaid patient in the hospital revenue? Let's do it here. This model changed the basically changed the dependent variable to the hospital revenue, correct? This is here, and if you look at this model, you can see the impact of Medicare discharge ratio is minus and significant. The impact of Medicaid is positive and non-significant. So if you look at this, answering to this question, the impact of the Medicare and Medicaid is opposite. We expected to see higher income, higher revenue for the hospital that accepted Medicaid, and we expected to have lower revenue. So this is significant in the Medicare, but not significant in Medicare. So basically, the impact of Medicare is a negative and significant. There's no impact of the Medicaid ratio. And finally, the last question is for the last model, add hospital bed per capita and household income and discuss your findings. Based on your finding, please recommend 3 policies to improve hospital performance. Please make sure to use the final model for your recommendation. Please also add 2 policy recommendations for community. For example, how do you treat household with lower income? Okay, let's run the code first. What is my state? Okay, here I have 2 more variables, correct? Hospital per capita bed and median household income. And if I run these codes and I look at the coefficient, I have here per capita bed and the median household income. The per capita bed and median household income, both of them has significant impact on the hospital revenue. The per capita bed has negative impact, but the median household income has a positive impact. So if I want to use this model and answer to this question, where is my word? Okay, based on your findings, please recommend 3 policies to improve hospital performance. To have higher performance, hospital need, these are significant, right? We can discuss on the significant section. We have 5 different significant, so we could go with 5 different policies, kind of different policies. First of all, being a system membership is a positive impact, has positive impact. So hospital could join the other company, other hospital, or being part of the system. The other is a total hospital cost. Okay, so okay, let's see. Total hospital cost has positive impact on the hospital revenue. The reason is whenever you have a higher revenue, you you must not have the higher cost. Probably this is the opposite side, because the impact of the hospital cost is positive, is significant on the hospital revenue based on the benefit. So basically, if I want to have, if I want to have more benefit, I do expect to have a lower cost, right? So because there is a positive relationship between the hospital revenue and the hospital cost, I do expect the lower cost to improve the hospital performance. This is the other suggestion for this. Medicare discharge ratio has a negative impact um, on the hospital revenue. We cannot say hospitals are not going to accept to admit Medicare patients, right? This is not a good suggestion. But I can say this is the policy. This is the kind of the policy recommendation. If hospital admitted more Medicare patient, they expected to receive more benefit from the subsidized, from the other governmental benefits. This is kind of the discussion you could have here. And if you go with the per capita bed, the per capita bed is a lower, right? The per capita bed is, it does mean if you increase 1 unit bed, you expected to have -1 unit revenue. So to improve the revenue, either you can increase, you need to be in the higher competitive markets, because whenever you have a lower per capita bed, you are in the higher competitive market, so you could have more revenue than the, and then you could have more revenue for each bed, because the impact of the per capita bed is a negative impact. So being in the high competitive market, you can reduce the per capita in bed ratio, and then you could have a higher income, higher revenue in the hospital. And finally, for the Medicare median household income, you have a positive, and this is completely correct, because whenever the hospital are located in the community with a higher median income, they expected to receive more patients. And the policy for the socio-economic variable in terms of the SEC variable is, if hospitals are located in the location with a lower median household income, they expected to receive higher benefit from the public resources. We have two recommendations here. One for Medicare patient, hospital with higher Medicare patient, they expected to receive, and the Medicare patient are vulnerable groups, because there are people that are not working. They are the retired people more likely. So two recommendations for this SEC variable, the socioeconomic status, is receiving more benefit for the hospital who admitted more Medicare, and they're receiving more benefit for the hospital that are located in the community with lower median income. This is two policy kind of policy. You can just think about any other things, but this is the policy I think it's better. Okay, and this is all about this final exam. I believe there's there any other question? No, this is nothing here. And based on evaluation of your exercise, some of you just, for the R square, you don't just the R square, you don't need to just report the standard error. So some of you reported the standard error, just, and make sure to just report the R square, not adjusted R square. This is the R square here, the first one. The adjusted R square is very similar, but so it's just it changes based on the degree of freedom, so I don't like to discuss more about this now. But the R square is just, you just report the R square. And I believe we have a few more minutes for any question if you have. Otherwise, I'm okay. I'm just finishing this final exam questions. I don't remember which place, which question. Oh, you are talking about line ones in question number 3. Okay, in question number 3, hopefully I remember that. I don't know what I said. So what was exactly the question? I really don't know what I said that. Let me go to the question number 3 and let me know what's the question here. Okay, here, number question. Oh, for this one, this section. Okay, okay, sure. Question number 2, section 3 is a regression model. The regression model is here. Let me review. This is a regression model for question number 3. And if you look at this one, is it the place? Okay, okay, okay. I'm explaining here. Probably it was here. So I just okay, here run a regression model and use the benefit as a dependent variable, Herfindahl index, system membership. Okay, here, yes, I remember that. You know, if you look at this output here, you can see there's a coefficient here, right? And all of the you can just everything that has a p-value less than 0.05 is significant. Basically, the impact of all other variable is not significant in the model, but you can see the direction of impact. For example, the hospital bed has a positive impact but not significant. Herfindahl index is negative, Medicaid ratio is negative, Medicaid is positive, and system membership is positive and significant. So based on this, I can say for this question, being a system membership increase the hospital revenue. If you remember your question later and I explain different things, please send me an email. Yep, you're welcome. Okay, class, any other question? Okay, I thank you, all of you. You are doing great. I'm glad to see you have a great performance. Excellent job, and we are almost finished. Please start working on the exercise, on the essay, on the final exam as soon as possible. If you did not finish, I know a few of you finished already. And please let me know if you have any question. Not, hopefully I covered everything in this video, and please watch the video again if you have any other question. It's okay, you can please send your email. I would be happy to help. Thank you, class. Have a good day. Thank you. Goodbye. Sure, you're welcome. I will do for sure. I will do for sure, Maria, at the moment. Sure, you're welcome. Goodbye. Okay, let me close this one. Okay, this is the end of video, and thank you everyone, and goodbye. Let me, oh, okay, stop sharing.